Good morning. My name is Kaushik, and today my topic in Big Data and Business Analytics is about overview of NoSQL databases. So, first of all, what is NoSQL? NoSQL database is a non-relational data management system that does not require a fixed schema. It avoids joins and easy to scale. The major purpose of using a NoSQL database is for distributed data stores with humongous data storage needs. NoSQL is used for big data and real-time web apps. For example, companies like Twitter, Facebook, and Google collect terabytes of user data every single day. NoSQL database stands for not only SQL or not SQL, though a better term would be no REL or no SQL Cotton. Carl Strauss introduced the NoSQL concept in 1998. Traditional RDBMS uses SQL syntax to store and retrieve data for further insights. Instead, a NoSQL database system encompasses a wide range of database technologies that can store structured, semi-structured, unstructured, and polymorphic data. Why is NoSQL? NoSQL emerged from a need: data storage, interconnected data, complex data structure. So coming to the data storage, the world's stored data, digital data is measured in exabytes. An exabyte is equal to 1 billion gigabytes of data. The amount of stored data added in 2006 was 161 exabytes. Just 4 years later, in 2010, the amount of data stored will be almost 1000 exabytes, which is an increase of over 500%. In other words, there's a lot of data being stored in the world, and it's just going to continue growing. Interconnected data. Data continues to become more connected. The creation of the web, fostered in hyperlinks, blogs, have pingbacks, and every major social network system has tags that tie things together. Major systems are built to be interconnected. Complex data structure. No SQL can handle hierarchical nested data structures easily. To accomplish the same thing in SQL, you would need multiple relational tables with all kinds of keys. In addition, there is a relationship between performance and data complexity. Performance can degrade in a traditional RDBMS as we store the massive amounts of data required in social networking applications and the semantic web. When should NoSQL be used? When a huge amount of data needs to be stored and retrieved, the relationship between the data you store is not that important. The data changes over time and is not structured. Support of constraints and joins is not required at the database level. The data is growing continuously, and you need to scale the database regularly to handle the data. No SQL categories. So we have key value databases, wide column stores, document databases, and graph databases. So coming to the key valuable databases. So these are a simple type of database where each item contains keys and values. The main idea is the existence of a hash table where there is a unique key and a pointer to a particular item of data. These mappings are usually accompanied by cache mechanisms to maximize performance. Example is the dynamo. White columns store data in tables, rows, and dynamic columns. There are still keys, but they point to multiple common columns. In the case of big table, rows are identified by a row key with the data stored and stored by this key. The columns are arranged by column family. Documented databases store data in documents similar to JSON, JavaScript object notation objects. Each document contains pairs of fields and values. The values can typically be a variety of types, including things like strings, numbers, booleans, arrays, or objects. So example is CouchDB. Graph databases store data in nodes and edges. Nodes typically store information about people, places, and things, while edges store information about the relationships between the nodes. NoSQL features. So here, each NoSQL database has its own unique features. At a high level, many NoSQL databases have the following features. So the first one is flexible schemas. Second one is horizontal scaling, and third one is fast queries due to data model. The fourth one is the ease of use for developers. Querying NoSQL. Many of the NoSQL platforms allow for RESTful interfaces to the data. Other offer query APIs. There are a couple of query tools that have been developed that attempt to query multiple NoSQL databases. These tools typically work across a single NoSQL category. One example is SparkQL. SparkQL is a declarative query specification design for graph databases. Here is an example of a SparkQL query that retrieves the URL of a particular blogger. So we have the prefix is FOAF and select is from URL from where contributor FOAM. So the name John Fober and the contributor FOAF is the weblog and the URL. Advantages of NoSQL. So this NoSQL can be used as a primary or analytic data source, big data capability. NoSQL has no single point of failure, easy replication, no need of separating caching layer. It provides fast performance and horizontal scalability. It can handle structured, semi-structured, and unstructured data with equal effect. Oriented programming, which is easy to use and flexible. The NoSQL databases don't need a dedicated high-performance server. Support key developer languages and platforms. NoSQL is simple to implement than using RDBMS. NoSQL handles big data which manages data velocity, variety, volume, and complexity. NoSQL excels at distributed database and a multi-data center operations. So the disadvantage of NoSQLs are it has no standardization rules, it has limited query capabilities, so the RDBMS databases and tools are comparatively mature. It does not offer any traditional database capabilities like consistency when multiple transactions are performed simultaneously. When the volume of data increases, it is difficult to maintain unique values as keys become difficult. Doesn't work as well with relational data. The learning curve of NoSQL is stiff for new developers. Open source options are not so popular for enterprises. Thank you.